So when we talk about following the scientific process and working with theories, there's really kind of two models that we use. First one's deductive, first one listed here. The second one's inductive. Deductive kind of starts at the top and works its way down. So it starts with a theory, and from the theory, there's hypothesis development, observation, and confirmation. And this is probably more common in the pure sciences, in the hard sciences, if you will. Best example here is if you look at Einstein's theory of relativity. Einstein essentially saw two competing theories, two problems that if you solved one, the other one was wrong, and if you solved for that one, then the first one was wrong. So he said, how can I make these fit together? And he did a series of what are called thought experiments, completely within his head, reasoning through how he could solve that conundrum between those two problems. And what he did with that is he came up with the general theory of relativity. He thought it through as a thought experiment. He went and he did, worked through the mathematics that supported it, and completely without external observation came up with his theory of relativity, or actually a special theory of relativity. Ever since then, people have been pulling out specific hypotheses and testing them with observations. So if, without going too deep on that, if you know a little bit about theory of relativity, things moving very quickly towards us will look a little bit bluer. Things moving very quickly away from us will look red, blue shift, red shift. That's testable, right? So I take your theory and say, well, here's a conclusion in the real world. If we see things moving very, very fast in space, they should exhibit a shift based on whether they're moving towards us or away from us. I can test that with observation. Again, has been done for years, and that has led to a confirmation that, okay, that component of the theory is correct, because we do see blue shift and red shift. And you see it in sound waves the same way. It's called the Doppler effect. And if you're watching the local weather, you hear about Doppler radar. It's because the waves that bounce off are changed in speed based on what they encounter. They're sped up by those, or they're shortened by those that are by objects moving closer to us, and they're spread out by those moving further away. So we have a purely deductive theory there. Inductive models kind of start with the opposite end of the spectrum. We start with the observation, observing in the real world. I'm going to go back to that example I gave of the president asking us to kind of do some focus groups within her company. We had no theory. We had no idea. We knew that she wanted to know what was going on in the organization. And so we started doing some interviews and focus groups, and that was our observation. Rather quickly, we started seeing a pattern, and the pattern was people were frustrated. And they were frustrated about a number of things, but I'll pick on one of them. And one of them was that they didn't understand the strategy of the organization. They were unclear, and it made them scared because they had bought another company and they weren't sure how it fit in because it was very different. And so from the observations we set up, we started seeing a pattern of, okay, well, let's see, they don't really know where the organization's going. They don't have a clear understanding of how they can help it be successful, and they're kind of scared about that because they don't know what to do to impact their own future. So that was our tentative hypothesis, right? We kind of started to see that pattern occur, and we started to draw out this tentative hypothesis. As we went through and did more and more observations, that pattern got stronger and stronger and stronger until we were comfortable saying, okay, here is the challenge your organization is facing. And that was our theory. Again, it's small ball theory, right? It's in the small world. It's not like theory of relativity, but the process is identical. So you work from what you see to something you see over and over again to, I think this is a recurring pattern that's likely going to be held, to here's what is going on in the organization, understanding the constraints of how that information was collected. So inductive models, deductive models. The reason these are important is because you kind of need to know which approach you're taking, and it does speak to different methods. If you notice, the first the first method got down to some hard measurement. This method started off with a lot of observation and soft measurement. So it's important for you to know, walking into your own research, am I starting with trying to prove a theory, or am I trying to understand what's going on? And so back to answering those two questions, right? So it becomes important in that it dictates some of your methods, it dictates your approach, it dictates what you look for in your lit reviews and your understanding of the constructs that you're trying to study. In reality, most theory is built this way. It starts with either inductive or deductive, right? So I'm going to pick inductive. Starts with an observation, pattern development. You come up with a theory. The theory kind of becomes a bigger concept. You publish a little bit about it. You talk to people about it. They start to say, well, let's go test that. So they find a way to test those specifics. So I'm going to take my small example, and again, this is a small example of my client. It would have been really easy to say, okay, so that's your theory. Let's do this. Why don't we take one group, say the marketing group, and let's do a policy deployment or a strategy deployment workshop with them and see if that changes their situation. Because you're telling me, your theory is that there's a frustration, and that frustration is being driven primarily by the fact that they don't understand what the strategy is and how to go forward. So let's take one part of the organization and test that, right? And so now we've gone inductive, built up to a theory, now deductive. Let's figure out a way to put that into a practice and into a test. And then usually what happens is you go back to inductive, you go back to observations and see what's working and what's not, where the theory applies, where it doesn't. And you kind of cycle back and forth between those. So in the bigger picture, the bigger development of theories in the world, that's primarily how they work. It either starts with inductive or deductive, and then it oscillates back and forth between the two to sharpen, to improve, to make the theory more generalizable and better.